Hello, before starting this video, I didn't mention anything about the formula and how did I get there. Um, the formula can be found on Wiki, the trilinear interpolation. It's about cubes and how to find a value of regardless to the corners. You can see you can also use matrices, but imagine the cost efficiency. Yeah, these are five formulas, five multiplications, and you're done. It's awful. See you, see you guys. I just want to see myself commenting. See you later. Hello everyone, this is Caplitero. Welcome back to a new episode. Today we're gonna talk about value noise once again. I already tried to make one video. I did it, but when I wanted to uh, how do you say it? Compile it? I wanted to check it. I didn't have a noise, any noise. So I have to do this once again. Thank you, uh, Asus, for this beautiful microphone. But there's no problem. Value noise, already did it. Let's call this new value. Starting with SFML template label. This is the window class. And we're gonna go to our, this is my value noise. You know it, guys. We did it once. Create a new header file, call this value class. And add this to here. What we're gonna do is int size z equals 0. Let's call this size of z axis array. This is linear interpolation. This is bilinear interpolation because we're using a 2x2 grid, and we're gonna use trilinear interpolation for our new noise function. This will be full of noise 3D, and we're gonna copy this and paste it here. So we're also gonna have a third loop called z equals 0, z smaller than size z, z plus plus. Here we're gonna have pitch z equals size z, shift to the right. We're gonna have also a starting point, times pitch z, and an ending for z 0 plus pitch, the modulus of size z. Because let's show you real fast. We have in binary interpolation, we have a point between lines here, and we're gonna check these points 0, 1, 1, 0, I 0, I 1. I'm gonna check interpolation between these points. We create a line, it actually on this spot, so it's gonna be here. Gonna have values from this these points. Okay, this is bilinear, and in trilinear we're gonna have a cube, and you know how a cube works. A point, 8 points, gonna have 8 points, and we need to find all these points. Okay, so how are we gonna find these points? First of all, let's create a new transformation. This is a weight for our z0 divided by float of hc. Okay, everything nice and clear. And now, you know what this is. This is a better way of linear interpolation. It's actually on cosine. It gives a smoother line. Okay, now let's keep this and duplicate it. Now the hard part. These are the points. So I'm gonna have a corner, and you can see these are the coordinates: x0, x0, I0, z0. So I'm gonna have x0 plus the I coordinate. It's gonna be size of x times I0. So we know our coordinate plus I coordinate plus z coordinate is gonna be size x times size I. Z0. Okay, gonna copy and paste for all the corners. Okay. Here all the corners we have. Let me check real quick. Here I have a list with all the points. Okay. C000, C001, C010, C011. Now we go down. 10, 110, C111. Okay, and where you see 1, you put 1. So 1, what else? And here's like this. Let me check if I can hear myself. Yeah, I can. Oh, okay. Corner, 1, 1. Here we have 1, 1, and 1, 1. We found our corners, so we need to interpolate between them so we can find the distance from the closer x distance. So this will be linear interpolation between C00, 0 and C11, EX. This is the distance between the points and making a interpolation between them. So we get a approximation from the we can calculate to what corner it is closer and give it the a closer uh value 0 1 C110 C01 and dx. More corners. I have 1 and 1. It will be the, let me check, C 1 1 1 1. After finding the z coordinate, we're gonna look for our I coordinate. 0 equals linear interpolation between c00, c10, dy, and float c1 equals linear interpolation between c1, c01, and c11, di. Anything else? I don't think so. So we're gonna go delete this. And here, this is the linear interpolation. So linear interpolation of C0, C1, and dx. We can find our z value. I hope this is everything. Here we're gonna have size of C, but we don't have a Z, so we're gonna go size C equals 1, size Z equals size Z. We're gonna have size Z times size Z, and here we're gonna have size Z. Also here, we're gonna have a function if size Z bigger than 1, dimension equals 3, else we have dimension 2. Here we're gonna have if dimension equals 3, we're gonna have if the noise the just like we have down octaves minus minus, else here everything. And now here in our window, I already have the window down. I'll put it here and explain it real quick how it works. Let's check value noise. I don't have value noise when I have a value class. Let me see. What's the problem? Okay, we have tile width, tile height, and tile depth. This is the the cube you're gonna use. This is the position in space at which we are inside the cube. Changes will be every time we change something, we're gonna redo the map. If you don't change anything and we just want to pass through it, we go without any changes. So we don't transform the map every time. It's a lose of time, useless. So gonna new new map with a new seed, transform the seed, initialize the map, and here, yeah, it says, um, here we have the update row, x times z, x times I, y. Window coordinate is the place on the window because the map will be on the window, and index texture will be the point in the cube, inside the cube. So y is 10 because it has small values, and we're gonna use a value here to transform it. Let's check it. One more problem. What's the problem? Here? No. Here. Value noise. So this head has that. This has. Okay. It starts. Let's check if it works. It will be small because a cube at that size is it's hard for the computer to process every second. So we'll have to it works the compiler for. Oh, what's the problem? Oh, right, here's the problem. Because we're adding x plus I times size x plus z times size x times size z times size. It was outputting the point to a different place, and it's no good. I hope so. That's the only problem. We'll see in a second, but I told you. Computer compiling debugger. Okay. Uh, this is also beautiful. We can pass through them, but there's one small problem. Where did I put something in the wrong place? 000 001 010 011 and 0001. Where did I go wrong? 000100 X. What's going on? See. Oh. I make so many mistakes. Yeah, we can change the octaves, add more noise. and we can pass through it. You can see it's beautiful. It's quite small, but if we want to make it bigger, we can go 100 to 100. But there's one small problem. Oh, actually, but let's wait for this. Um, I think we can go with high ground. I'll show you in a second. No, it's the same thing. Okay, let's add octaves a little and add noise. More noise, more noise. But if I want to change it, the cube, let's go for something interesting before we dive inside. Hmm, this one. Let's add more noise. Okay, and we're passing through the cube right to the end. It's beautiful. Thank you for watching, guys. And I hope this was useful. I'm trying to implement new things. I don't see many of them, so that's why I'm trying to do something interesting. And I'll make a video about cubes in in the future. This is I'm using this. And what can I say? Anything else? See you next time, guys.